Today we've got Wes Cartner from the NCDOT Aviation. He's going to be giving a presentation on UAV and coastal monitoring and adaptive mitigation planning. Quick little bio: location analysis specialist with a demonstrated history of working in the civil engineering industry, skilled in LiDAR, ortho imagery, UAS, CAD, global positioning systems, ArcGIS, ENVI, a plethora. Strong engineering professional with an MS in geoscience, focused in GIS and remote sensing from the University of North Carolina at Wilmington. Wes Cartner.
Well, good morning. Thank you so much for joining us today. I'll try to keep it light and get y'all out of here on time. Like Khalil said, I'm Wes Cartner with NCDOT. I kind of didn't give them a bio promptly, so I apologize. I'm with the Environmental Analysis Unit at NCDOT. I work very closely with aviation in getting all our UAS needs met for our environmental projects. One of them being our Body Island project out at the Outer Banks. So we're going to get into a little bit about how we're using UAVs for coastal monitoring and how they really play a major role in our adaptive mitigation planning at the NCDOT. Like Khalil said, I'm with the Environmental Analysis Unit at DOT in the Mitigation and Modeling Group. We've had successful experiences using drones, not only in the aerial pesticide, herbicide application area, but we've also had successful experiences doing Section 7 support surveys, helping our other biologic survey unit look for endangered species, survey habitats for other species, all in keeping permit accordance. So we really try to stretch our legs and help everybody on the environmental side. So here's just kind of a broad scale scope of map to look at what I'm about to get into, and it kind of explains that we had to bring everything that we were to utilize to this job site out there with us. There's not a whole lot of areas to get resources, to stage resources, anything out there on the coast. So just so you have an idea of roughly where we're operating from. And so why Body Island? Body Island, it was the purpose of the B-2500, the Bonner Bridge, known as the Bonner Bridge or the Mark Bassanite Bridge to the locals. It was the largest bridge project for the state of North Carolina, and it is the third largest continuous segmental concrete box girder bridge in North America. One of the purpose and needs for this project was to secure the evacuation route of NC-12. If you've been in North Carolina long enough, you know that NC-12 is historically notorious for flooding with any sign of rain or hurricane weather coming off the coast. So we were trying to figure out how to increase our emergency response times and evacuation measures out there on the coast. Like I said, it came with the B-2500 project. And if you'll remember the map that I showed you before, with DOT comes permitting, and with bridges projects, roadway projects, come environmental impacts. So we have to, sometimes we incur environmental impacts, but we have to have mitigation to meet those needs for our impacts. So like I said, out at the coast, there were not a lot of areas or opportunities to get those mitigation credits to get our permit. So we entered into an agreement with the National Park Service that essentially said they would like for us to come in and rehabilitate the 100 acres or so around the Body Island Lighthouse, because it was a significant cultural heritage area. So a very high valued resource area that had been overrun with the invasive species of Phragmites, which is a reed that can essentially grow anywhere from 5 foot in canopy height up to 15 feet in canopy height. And so that large growth of canopy height was preventing the natural vegetation from succeeding. The Phragmites essentially grows out, and competition of resources, it just ruins all the native vegetation. So here's a satellite image, not even a satellite image, from the photogrammetry unit, excuse me. This was taken back in 2008, I believe. The yellow, the orange is the original extent that they had mapped of the Phragmites, which totaled about 35 acres at that point in time. And as you know, it's an invasive. It is spreading rapidly out there. When they did this second comparison in 2011, it had gone back to 51 or up to 51 acres of live Phragmites stands. Since I've come onto the project for about 3.5, 4 years now, it had gotten upwards of 70 acres of treatment area. So not the entire 70 acres is covered with Phragmites, but there's enough pockets here and there that we have now taken on addressing upwards of 70 acres for our treatment plan. And so why are we treating it? We entered into an agreement with National Park Service to provide an adaptive management plan. So what is adaptive management planning? And it essentially says, we're going to come out here and try our best doing a new technology, a new method of treating this type of invasive species. It has not been done before. It has not been done in this manner, conducted in this operation. So we're going to try to have successful experiences, and we're going to model and capture our point in time and try to show a progressive approach to actually maintaining the Phragmites. So one of the key words is in spite of uncertainty. We aim to reduce that uncertainty over time with the continuation of the monitoring. So what describes the success of meeting that adaptive management plan? And so we had 3 success criteria, which were essentially, we needed to reduce the total overall acreage from the original first year mapping treatment, which I think started in 2018, might have been 2017 before I came on to it. And they had roughly 50 acres of it. And we were successful until COVID. Not being able to spray for 2 years kind of set us back. So the Phragmites was able to recoup and take over a couple more acres, but we are still working to get our total area of Phragmites back under first year treatment size. We needed to be able to prove through our UAS mapping or other mapping efforts that we were shrinking the overall footprint. So we can take 70 acres in one footprint, and then if 5 acres starts popping up way over here, or if 2 acres starts popping up over there, we still need to get 70 acres of that original footprint down to a manageable area. And like I mentioned earlier, the Phragmites canopy height, mature frag can get anywhere upwards of 10 to 15 feet. So we needed to be able to get that canopy height back down to a manageable stage for the National Park Service to continue these efforts. So they wanted us to get down their 70 acres of land down to about 10 acres of Phragmites with a stand height, a canopy height of 3 feet or less. That way they would be much more apt and susceptible to get in there and be able to handle it with their smaller crews. And so here's just a little snapshot. In our monitoring process, these are our vegetation point plots. And essentially, while we map the entire 70 acres every year, we try to go out and take snapshots of individual areas. We have about 13 different points that we will go navigate to with our drones and nadir direct down and try to take a snapshot of that one point. And so you can see that vegetation point 2 is on the left, and we try to assign a percentage of coverage. So when we map these 13 points in 2022, we can then come back in 2023 with repeatable accuracy with the GPS tag on this image, go to the same spot, take the same image, and we can compare. So 2022, this was about 10% of frag coverage versus 2023. Has it gone up or down? And it's kind of one of those snapshots to help monitor how effective our treatments are becoming. So on the left, you can see about a 10% coverage rate, and on the right, you can see about a 70% coverage. And so how did we end up with drones? National Park Service, Body Island was a historic wetland, a significant cultural heritage area. They did not want not only the visual disturbance of people with backpack sprayers and Tyvek suits roaming around one of their key tourism situations with all of our tourists out there. They did not want us to be disturbing the ground. So how do we go out and treat 70 acres of marsh without putting feet on the ground to do it? Traversing also that marsh environment would be very difficult between the standing water, the thick vegetation, the snakes, the ticks, all the other crawly things that come with those wonderful environments and ecosystems. There were also multiple state and federal protected species that would not have been as easily protected if we were to go with a traditional manned unit via helicopter or airplane. Also, this was 70 acres out on the coast with no airstrip for an agricultural airplane to land and load and stage. So we were unable and unsuccessful in getting bids for manned units to come out there to do this treatment. So without being able to even get a manned unit to come out there and not being able to put feet on the ground, we arrived at trying to utilize the drones to treat these areas. There's the snapshot of our overall map again. And so here's the Body Island boundary, the project boundary. And so this was our treatment area from 2022. You can see the red oval boundary being our project boundary, and then the blue tinted area being the actual UAS treatment area. And so that was comprised of about 58 to 59 acres. And just to go ahead and point it out, you can see the big blue shaded area is the UAS treated area. And then if you'll look in the lower left, you can kind of see these very small yellow outlined polygons. Those were hand treated areas. So when I tell you that in the same 2.5 days that it took for a 4-man crew to aerially treat and applicate pesticide for 60 acres, the same gentleman that was doing the backpack spraying was able to treat 1.12 acres. So 2.5 days for 1 acre or 2.5 days for 60 acres. And so just to show a little bit into the background, we fly a Wingtra platform because it's on the Blue UAS list. National Park Service being also part of the Department of Interior, big government, not allowed to have foreign drones manufacturers. So no DJI, none of your off-the-shelf stuff that is easily and cheaper, more accessible. So we had to go get a Wingtra platform from our friends over at Aviation. And we fly 2 flights with this one. We fly an RGB flight with the Sony XR1, and then we also fly a multispectral flight with the Red Edge, the MicaSense Red Edge. And we take these high resolution images, and essentially we have an RGB, which is going to serve as our ortho, and we are able to overlay that, combine it with our multispectral data. And so we are out there trying to isolate the spectral returns of the Phragmites. And so we use these 2 forms of imagery to highlight our areas of treatment. And so here's just an output from the RGB camera, just to show the definition, the actual resolution that you can get from these resources, these UAS platforms. They've come a long way than where they were, even 5 years ago. This is the observation deck that is in the middle of the swamp. So this kind of just shows the ability to capture not only your shallow water bay area right there, you can then see the drier marsh on into your greener vegetation. So just we're really able to isolate a lot of the signatures that we're after. And so while we do try to maintain the best resolution and accuracy that we can, we do fly this site every year, multiple times a year. So we do have control set on the site to maintain those base stations and our GPS accuracies. We do try to make sure that the mapping products that we're putting out are relative to the area. So I believe we have 9 control points, usually, at least when they're not being destroyed by the hurricanes. And then we also deploy a couple of the arrow points in random areas every time. So that really enables us to keep those accuracies up there. And so here is basically the final product of what we were after from a mapping standpoint. On the left, you can see essentially a delineation model or the predictive model of the Phragmites in the purple polygon. And this was done for us by UNCW and now is done for us by GeoOwl. Miss Carrie Mapes sitting here with us today. They're able to essentially provide these areas of interest of Phragmites, and we were able to essentially draw polygons around them and then upload those for flight plans for the treatment. And so you can see what the RGB image as a base map on the left is, and then that is compared or not compared, that is added to the multispectral data returns that we have on the right. And that is how we delineate out those Phragmites. areas. So here's just another little zoom in, how you can see the different end surfaces. The water here is red on one side, but then the parking lot. So just to be able to pick up those different signatures and reflectances have been crucial for us. And so here is our change detection from 2019 to 2022. And it's the same outline of the boundary, but you can see that red, that bright red in the middle has changed to non-phragmites. Those are the treatment areas that we spray every year. And so you can see what has changed to phragmites, what has changed from phragmites, and what remained the same. And so we are finding that our treatments are very, very successful, but being able to maintain application every year is becoming to be crucial. We have now sprayed out there three seasons. And what we are finding is that the biofuel, the dead mass of all of the phragmites and other vegetation that we are killing have basically just piled up out there. And so we're currently trying to work with the Forest Service to come out there and conduct a controlled burn on the property, which is also one of the key components in most phragmites plans, treatment plans. They do recommend trying to burn it because the more you get into it, boots on the ground, the more likely you are to spread the phragmites around. So we are trying to burn all of the biomass that we have created over the past 3 years in efforts to really bring home the treatment plan of once we spray and treat everything, phragmites included, that gives the natural seed bank and the natural vegetation a chance to root first and come back and hopefully be more sustainable and outlast the phragmites in that capacity. And so here's another close-up of the actual phragmites returns in the model that we get and how we get the delineation boundaries around it. And so what do I do with that data? Essentially, here is the same red outline of the project boundary. I can then take all of the GIS data that we've accrued and the delineated polygons and upload them into our aerial pesticide applicator. And I'm able to make individual flight plans per polygon that we have delineated out. So you can just see right here that this is, we've taken the delineation and put it directly into a flight plan treatment area. Our aerial pesticide applicator is a Helios AG110. We can treat roughly 6 to 7 acres an hour with a 3-man team versus, traditional backpack methods that, I showed you the graph earlier that they're much slower. So with these repeatable results, we were able to dial it in and do this 60-acre project in about 2.5 days. And so our next steps, like I mentioned, we've now sprayed successfully for 3 seasons. The National Seashore, the Cape Hatteras National Seashore, has not exactly firmed up their fire suppression plan yet, so they're not willing to let us conduct our controlled burn, but that is where we are headed hopefully this winter. We have a contact at the Forest Service that they have an M600, and they get to drop the dragon eggs, so it's basically a flammable ping pong ball. So we're going to hope we can go out there and use the same flight plans and GPS and GIS shape files that we have and use this platform to conduct our controlled burn. And just to recap, the drones that we use are GPS guided from GIS acquired shape files. So we know that we're staying spatially in the same area. It's repeatable, it's accurate, and it's way more efficient than the traditional manned methods that we've tried to employ in the past. Consistent mapping and the change detection we're able to provide year over year with those monitoring efforts has been crucial to proving the success of this site. Also safety. It's much easier to fly a drone out into 70 acres of swampland than actually walk through with it with a backpack, either pesticide full or even a backpack GPS. Those are not fun after a long day in the swamp. And so right here, I'll leave you with a video. I believe somebody may have to click the play button on it if she's, yep. And this is just an overall capture of everything that you've seen now from from the beginning to the end. This is the aerial herbicide applicator flying out at Body Island. And we are treating right here at the boardwalk that you can see. So we've got multiple drone platforms flying around, taking this video, doing the actual application and whatnot. So I'll let y'all watch this if it doesn't freeze on us, but are there any questions while you enjoy? Yes, sir.
So I'm interested in kind of a little bit of the biology here. Has there been any genetic studies looking at the genetic diversity to see if this is a single introduction situation or multiple introductions? I mean, it's one thing to treat, but if you have a common occurrence of this reoccurring on its own, we'll be treating this forever.
So we're hopeful not to treat this forever, but as it is an invasive species, it is inherently going to come back at some point. We are not guaranteeing full eradication. So we are treating it to get it under a manageable level for national park standards, for the National Park Service to continue these efforts. So I don't know if I addressed that how you wanted it, but yes, sir. Anybody else?
You had showed an image earlier in the presentation that had I think like 10% and like 70%.
Yes, ma'am. The
So-
vegetation plots?
Yeah. So just like a question on scale. I wasn't totally sure what I was looking at there. Was that? Yeah.
Do what? So we typically fly out and we're at an altitude of maybe 25 to 40 feet. And so that's probably about, 10 yards, 10 yards square, 10 yards. So it's a very isolated area, but that is why we also take 13 different points around our 70 acres to try to give an accurate representation. Because you see the overarching model of how sparse it can be versus how populous it can be in some areas. So we try to just show a snapshot of one location at a time and keep going back to that same point. So it's very, very small and locale.
Awesome. Thank you.
Yes, ma'am.
Anyone else questions? There's no questions from the chat so far.
Awesome. Thank you so much.